really happy to see all of you here, and I hope that you're going to have a great day, and so welcome again. I will have a very short keynote. I want to save all the time for you. This is your conference, this is your meeting, and we're going to share some applications. I'd like simply to give a very short update on NI. We're doing very well. We did a great second quarter. And everybody can hear me? Everything's fine? Okay, better? Yeah, this seems to work now. Perfect. So we did a great Q2. We're doing very well and very nice 2013. We are growing. Why this is important for you? Because a lot of that growth and profit is completely reinvested. We're in applications, in R&D, and in people that is supporting your activities and your research. We have more than 600 technical engineers on the field that are your technical consultants. We invest 18% of our revenue in R&D, and we are very focused on control, measurement, and diagnostic devices. That is all our business, and all our investment are on that. So you have in NI a partner that is keeping investing and keeping putting money on platforms and technologies that you're going to use on your research and control system. We have a small team with a worldwide footprint, and we are working only and exclusively with national lab and research centers all around the world. And we apply the commercial off-the-shelf technology, customizing where it's needed for your needs. And we have also a professional team inside NI and in our partners in order to customize and integrate systems. These are only a small picture of all our customers all around the world. And we really touch all the national labs, all the major physics institutes around the world. Our colleague, the academic team, has today more than 400 professors from all around the world, and we are present in 7,000 universities here today. Today we're going to have a presentation from some of the US National Labs, from CERN, and from other labs and institutions around the world. And the first keynote will be given by the director, the scientific director of the LNLS, that is the Brazilian synchrotron. And they have in Brazil a very incredible project to develop also a larger synchrotron in Campinas. We will hear more about that during the day. I want to spend a few words about the partners, and you will see in this keynote points that you will see during the 3 days of NIWeek that will start tomorrow. First of all, the focus on professional partners that can really help you and NI to deliver systems that are perfectly tailored for your needs. We have more than 700 partners around the world. Many of those are specialized exclusively in big physics application, and they live only on that world. And the model that we use is that we have a standard product, and we can build on that the application and the customer application that you need, in order to have a customer solution that fit completely your requirements. And we're going to have today some presentation from this partner that have all the sites, but all the specialization, from Verigo to Evopro, Tesella, and other. And we have also other partners like Cosilab and Enstec that are very well known in either the Department of Energy or in the physics community outside the US. Now, the deep physics requirements are changing as technology is changing, and are changing, becoming always more complex. Many of you remember the first accelerators of the first control system of the first diagnostic. As I remember, probably the very first digital digitizer. And they were completely, let's say, easier to control, and the applications were much less complex than today. So with the increase of the complexity, also the diagnostic, measuring, and control system increase exponentially their complexity. And also the technology that is needed to control this experiment is pretty much evolving with the technology and with the complexity. So if we look at the NI platform, and it is divided in 2 layers, and the integration between these 2 layers is the fundamental advantages that our technology offers. So the software layer that works also with any kind of hardware, not only the National Instrument hardware, is completely integrated with hardware. The NI hardware can work with any kind of software. So the 2 layers are independent. Still, you maximize the efficiency and the capability of the development when these 2 layers work together. And so the hardware layer are based in 2 main platforms that are PixI and Comparillo. And of course, we have all the PC-based instrumentation and data acquisition part. And the software layer is really divided into 2 pieces. One is the driver layer that makes the hardware alive in the operating system and in the bus that you're using, and the API. And API, we have mainly 2 API, LabVIEW and LabWindows, that are running in different operating systems and that we keep updated. And you will see a lot of news about LabVIEW 2014 this year. Now, we mentioned that the main point of our team is to collaborate with you, with the National Lab, in order to develop these applications that are typical of this world, like the lifecycle management, the EPIC support, the RAS, the Linux support, radiation and magnetic test. And on the back we have a demo that we developed for ITER, where you can find all these characteristics, the Linux driver, the EPIC interface, the magnetic test, the radiation test, the RAS, and all these are packaged in order that all the domestic agencies around the world can leverage what ITER.io is doing very easily and very smooth. Now, some of these tests, like the radiation test, is really, there are not many companies that can offer you radiation tests on the platform, on the product that you want to use. And these radiation tests are performed in National Lab and are public results, as well as the magnetic test on our equipment. And I think that is a really unique advantages using national instruments. Also the RAS, the reliability, availability, serviceability, and manageability of this system. And you have all the life cycle managed by NI with you, and we provide all the data available in order to have the best uptime possible for your machine. And for instance, we are here in Austin, and for who of you is interested, we can host you in our system reliability lab, where we test with dirty power or very tough situation, the hardware, the real hardware that you're going to use, and not just the hardware, also with the software that we will write with you in order to understand how to perform the hardware under that condition with the software that is analyzed with you. We had with one national lab an example where the hardware was performing below our statistical and measured information because the software was, for instance, recalibrating and resetting continuously our digitizer. And so we reached the expected life of the switch in much shorter time. This is how the software is influencing the hardware life. So if we don't work together, it will be very, very difficult to reach the exact date and to keep the cost of management and the cost of ownership of the system within the budget time. I want to use this as an example where cooperation between CERN and National Instrument to develop a special chassis that has high availability with 2 power supply and a power supply bridge that alternate or use the proper power supply completely hot swappable from the front. And this system managed to teach us, we learn, thanks to CERN, how to have also the monitor the health of your asset. In this specific case, our chassis has a second completely redundant independent Ethernet that is monitoring the health of the chassis, allowing us to insert to monitor what's happening. And this is a concept that we extended to a much larger family of products. And you will you will attend this week, to the introduction of what we call Inside CM, where CM is monitoring control, conditioning monitoring, and how we can bring this to enterprise level. And so our software really became an enterprise level in order to keep your experiment, your machine with a very high uptime. And if we focus now on one of the technology trends that is influencing also and mainly the scientific research, I will spend a few seconds on what they call the big Alan data revolution. You're going to hear this week about industrial Internet of Things, cyber-physical system, analytics, all points that are very, very important also for you. And in one of the national labs, we were negotiating very hard about the requirements and the cost of a digitizer. And after we moved in another conversation, and they show us the beauty of this incredible data center. And only there I realized that sometimes engineers and us have a misconception. We want to spend a lot of money on the data management and on the data processing, because there is the real information, but we forget that if we don't measure all the chain with the same quality, we risk to have data garbage. Analytics companies are reporting the world that almost 80% of the measurement taken on the industry, I'm not talking about only the research world, are unuseful or are not correct. 80%. An incredible large data. It's not, we are not acquiring data, we are acquiring a lot of unrelated data to our experiment. So if we focus on that, science means discovery and innovation, and we're moving from experimental science to theoretical science, from computational science, and now we arrive to the data-intensive science that include all the chain of the measurement, from the sensor to the digitizer, the data acquisition system, up to the analytics and the data management. So this is really the big data revolution that we are going to have in these days, in these years, and everything is around this concept. Now, we're going to have a lot of variety, volume, velocity, value, but it's important for science also visibility of this data. And when we talk about big data, we are not talking about the social media data or the data that grocery store chain want to measure to understand what we eat or what we prefer. We are talking really about engineering and scientific data, and we are focused on that. And this is the oldest, fastest, and biggest of all the other big data. And about this, we know the chain of measurement and control. There are sensor actuators, there is the data acquisition analysis, and after there is the back office IT infrastructure, where we are running now analytics that can really, for instance, predict failure in your machine, can help scientists to understand what's happening in the experiment. And these, CERN, Berkeley, and other national labs are really leading for one fundamental measure, that is the time measure. We need to have deterministic and very fast timing and synchronization capability on the network that is connecting all these instrumentations and diagnostic system. And this is where the data flow in real time and is increasing the value of this information. And this is where NI is working, and you will see during these 3 days there will be a lot of focus on these topics. And I want to conclude with just an example that we are working with ETH, the University of Zurich, for a very large data acquisition system with 50 microseconds of closed loop between hundreds of input and hundreds of output. And the data acquisition analysis system needs really to have basically an hardware in the loop with 50 microseconds for more than 1,000 channels. And all the data analyzed are processed with our friend from HP that with their moonshot technology are taking the data from our PixEye and managing this system. So from the sensor to the back office, and the heart of the system, of course, is the FPGA-based measurement that NI does for this very close hardware in the loop system. And more information will come today about this. So, today's presentation, again, this is your conference, is your summit. We are really here to hear about your application. This is the agenda up to lunch. You have also on your desk the updated one, and this is after lunch. Now, our team is really excited to keep working with you, and our team is expanding with the support of partners like, again, NSTEC and COSILA on a more global perspective, but also many other local partners that are working